Click to begin recording. All right, so we've now talked about the hardware. Some things to remember about the control system before we put the code or go through the process of putting the code down onto the controller. All the blue boxes are updatable from that slide. Every one of them. So you're going to want to check for updates every Monday. I just want to reiterate that. Do it, do it, do it. You don't want to come to competition with the old code, because then you might have to update at competition, which means now you've got a new set of code, and it almost never breaks the old robot code. But every once in a while I've had teams tell me that once they did the update, their old robot code broke. I don't necessarily believe them all the time, but they say that that happens. And so you want to get a new update on your machine as quickly as possible so you can so that you can put a new image down on your serial controller, and you can put your robot code down in the controller so you can test it with the new code. You want that to happen as quickly as possible. That's why it's important to be very on top of updates. Okay? Next, the robot is both the driver station, whether that's on your development machine or on the driver station itself, and the robot together. So if you've got robot and your robot isn't working, make sure that you've enabled it in the driver station. Make sure that the driver station is set up correctly, right? That's a very common thing, all right? If you're having any problem talking between the two, drop your firewall, drop your antivirus. That's step number one. Okay, so now we're to the point where you can make LabVIEW code that will run in teleop and arcade mode. You don't need to know any code to do that, any coding skills. You don't have to know a thing except what I'm about to tell you. So, how do you get started? In LabVIEW, there's a getting started window when you open it. So I'm going to continue recording, and I'm going to come over to LabVIEW. And I actually went through the process just a second ago, so I'm going to delete what I did so you can see all the steps of the process. When you open up LabVIEW, which is under All Programs, National Instruments, and LabVIEW 2013. Notice, by the way, I've got LabVIEW 2012, I've got LabVIEW 2011, I've got the professional version of LabVIEW. If you're a mentor, you can have all those things on your machine at the same time. They will play together. If you come into LabVIEW and open it after you've installed the utilities, so this won't do this until you've installed the utilities, you will get a startup screen that looks like this. The startup screen has tutorials in it. This is where you can get information about how to set up the controlling system, how to set up the, oh look, there it is. There's the access camera, right? How to set up all the utilities, all the things we've talked about so far. There are tutorials for setting all this stuff up. So if you forget everything that I've said today, it's all in the tool. But it's pretty easy to make an FRC serial robot project. Notice under New, FRC serial robot project. So I can click that. And my suggestion is that you do this after I do it, and just watch here for a second, because then you will watch, absorb, and try to redo it again, which is actually pedagogically better for you than trying to do it with me. And then if you miss something, then you miss everything else I say. And everything that I say is incredibly important, as we've already decided. All right? Great. So I'm going to give this a title. I'm going to call this my FRC training robot. And I'm going to give you a tip. What day is it? It's the 11th of January. So I'm going to call this January 1, 2014. What time of day is it? It looks like it's 1. Oh, sorry, I'm in Eastern time. 12:19 p.m. Now that may seem like a lot of extra work. Like, why would I make that stupid long name? Well, your code is going to evolve over time. And if you continually save new versions with this process, okay, you're going to know when a piece of code was from. And at some point, you're going to make a code change that's going to break everything. And probably, if you're not very disciplined, you're going to have made 7 programming changes. And then you're going to test it, and it's broken. And so you got to go back to the time when it worked and figure out which of those changes didn't happen right. So by saving programs this way with this type of naming convention, you can at least know when a program was made. Does that make sense? So it may seem like a lot of work up front, but it's not. Okay, there are two robot types that you can make. When we go through the process together in a second, we're going to make a simulated robot. So there's a section here, there are 3 of these that say simulation. The only thing that I have to choose about the robot that I make is what's the drive. So what are the drives? Arcade, which is where you have one joystick, and its Y turns into the forward back, and its X turns into the whether you're turning or not, right? There's Mecanum, which means that you have omnidirectional wheels. I'm not going to talk about that because it's advanced and this is a basics course, okay? And then there's tank mode, which is not here. We'll modify arcade drive to go into tank mode later, but we'll just start from arcade mode now. So this is hardware or simulation. This is going to make a much bigger piece of code that can be either used on your robot or can be used in simulation mode. If you don't want to have the time investment of making the whole big nasty code that can also be simulated, you can just do hardware only. But we're going to do hardware and simulation. Okay? This is going to make a smaller code set. This is going to make a larger code set. But it's going to be good for us to make that. The big thing that's important after I pick the drive that I'm choosing is to make sure that I put in my number correctly. Chicago Knight's number is 1739. If you haven't put these numbers in correctly, then the code isn't going to go to the right location. It's not going to go to the right IP address. It isn't going to work. Okay? So, I hit finish. I've got a nicely named project. Wow, that was fast. Woo, they've improved that since last year. That's exciting. This is what's called a project window. This is the Project Explorer, and I can tell it's the Project Explorer because when I pull this out, guess what it says at the top? Project Explorer, right? So it's not rocket science all the time, although it is sometimes. The Project Explorer, just so I can explain it a little bit, it organizes things both on the computer that's in front of me and on any computer that has LabVIEW on it that's attached to my computer over the internet. So I would have, in my laboratory, I would have my development machine and what other computer? What other computer is out there? I've got my development machine. I got a driver station, probably. That's another computer. What's the third computer? The C-RIO. That's the robot controller. That's a computer, right? It's an actual computer. And so I've got another computer here that's called my Compact Rio C-RIO target. I can check to make sure I put the IP address in correctly. See that? 1739. If this isn't right, it isn't right. Oh, on the screen. Oh, I'm only looking at my own screen in front of me. So for you guys, I had to move it. Let's do that. That's better? Is that better? So right here, you can see now, look at what's in this. I've got team code, which we'll explore later. I've got support code, and I've got something called robot main. Guess where the code is for the robot? It's all in robot main, right? The code that's actually in there under this main program is this code. So guess what? When does this code run? It's called begin. At the beginning, right. When does this code run? It says autonomous. In autonomous mode, when does this code run? It's in teleop. Teleop, right? So the code is actually laid out in a way that maps to the game. And we're going to talk about these more later. But we don't have to know anything about the code to download it and run it. The way that you download and run is 2 parts. All right? First of all, you have to go into the build specifications under the target or the computer that you're trying to put the code on. I developed the code on my laptop that's in front of me, but I'm trying to put the code onto the C-RIO. Tap her. Tap her. There we go. Wake her up a little bit. There we go. Good. She's up. She's back. Got it. Right? This is a lot of stuff, and I understand that sleep patterns for for teenagers are tough, right? So it's tough to have this much concentration all at once. So I appreciate it. So we are going to build this. So under build specifications, we have something that describes how to take the code that's running on my laptop and rebuild it into what's going to go down on the Creo so that it will work on this new operating system that's appropriate for a robot. Is Windows appropriate for a robot? Does it ever crash? Every once in a while, right? It's an all-purpose programming, an all-purpose operating system. It's meant to make me feel good as a user. That's what Windows does, right? Or to feel bad. That's the same thing that Macintosh does. It's a general purpose operating system. On that robot controller, there's a real-time operating system that runs things when you want them to run, exactly. And the thing that it thinks is most important is whatever the computer, the program thinks is most important, not what the user thinks is most important. So we have to rebuild the code and put it down on that type of an operating system. You do that by, and if you learn one thing from this course, this is the most important thing. Whenever you don't know what to do in LabVIEW, or in anything that's associated with LabVIEW, right-click. Right-click early, often, all the time. And because I don't know how to build this code, but I can see that this is all set up as a specification, I right-click on it as my guess. And look what I get! By the way, the other important thing is you have to read. You can't just right-click on it and it does it. You sort of have to use your brain and read the next parts. All right? So what would I select to build the code appropriately? Oh, my goodness, there's something called build, right? So if I hit the build button, it will build the code that I just created, the robot main, that has all that subcode in it that's ready to be used on a robot that's got arcade mode. I would hit OK, and it's going to go through the build process. The build process can take some amount of time on certain machines, although I'm encouraged by how fast it built the project that maybe we've improved the speed of the building this time. I want you to see the amount of time that it takes because this is what's going to happen during competition. When you have to make changes to your code, every time you make changes to the code, you have to rebuild it if you want it to go down on the robot eventually, right? So it says this could take several minutes. What we're doing is we're making this code appropriate for the real-time operating system, okay? When this build finishes, it will need to be put down onto the robot. That's called running as a startup, okay? There is an option, this is also called deployment, and there's an option called deploy, right? But we don't want to do deploy, okay? Deploy puts the code down on the robot, so it'll be down there, but as soon as you depower the robot and repower it, it'll be gone, right? So when we build, we don't want to deploy. We want to get the code to go down to the robot by running as a startup. When you run as a startup, you're going to take the code you just built, which is still on the laptop, and it's going to translate down to the code, the robot controller. And if you depower the robot, if you've selected run as startup, as soon as you repower the robot, that's the first thing that will come up. And it's very important that you do not carry the robot while it is powered. So when you take it out of the field, if it's powered, you are breaking the rules, and that is dangerous, right? So you will have to depower the robot and turn it back on the field in competition. There were some teams that didn't do that for a little bit. And so they never learned how to deploy and run as a startup because they never thought they had to. You have to depower the robot to carry it. You have to repower it on the field. If you're not running as a startup, it will not repower. So whenever you make changes to the code, you build and you run as a startup. So let's go through that process. I believe, will this just do this as a simulation? So what we'll do when we come back is we'll go through the process in simulation with everybody, okay? Thank you very much. We're going to come back to the presentation here and here. I'm still learning to use Camtasia. And, oh, did I not record that? Oh man, I hope I recorded it. If not, I'll record it again while you guys are at lunch. So, let's go through doing this as a simulation. So, if I want to do simulated code, I do it up here. Oh yeah, that's right. If I'm going to do this in simulation, I open robot main and I switch the target. So let's open robot main for a second, and then I'll do this all again while you guys are eating lunch. And it'll be great. It's funny, I do this for 6 weeks of the year, and then I don't do it again for another 6 weeks. So when you open the robot main, you're opening a big piece of code. Remember, I said this is a bigger piece of code than hardware only, because hardware only goes to a robot. This has the ability to go to a simulated target. Down here, this is the front panel of the code. So when you open robot main, here you can see where you're going to run the code when it runs. See this? FRC training, blah, 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 and it's going to run on the real-time compact Rio, right? I can right-click on this and change the target to run on. Why did I right-click? Because I didn't know what to do. So you can right-click on anything, and you get all sorts of stuff that happen. Different things happen when you right-click on different things. When I right-click on this part of the code, I can switch this over to my computer. And then when I hit the Run button, it will run in simulation. I'd like to have you do it before we... Oh, and I need the driver's... Right, because it's both the robot, which is now simulated, and the driver station. So I got to have the driver station open, and that's fine. So it's going through the process of making all this stuff ready to go, and then I'm going to wait. I'm waiting. I'm waiting. I'm going to hit the Run button, and when I hit the Run button, a simulation window is going to come up, which is really cool. And we'll see if it works on this resolution. And then you should be able to open the driver station, enable the robot, hook up a joystick, and make the robot move around. And I'd like us all to do that either just before we go to lunch or just after we go to lunch. Okay? So you can either go to lunch, eat if you're hungry, or you can do it here, go to eat. We will start talking again at 1:15. Does that make sense? Have I got that right, John Sr.? Oh. Schedule is 12:30 to 1:15 is lunch. Okay, great. So watch this. I run the program. So we're done. We've done that. This thing is worrying about my firewall again, which is fine. Notice what it did. Wow, that's an even better environment than they had last time. They did a good job. So that's a simulated environment. It's a little weird to move around it, so you can click and do this. You can shift click and scroll to do that. You can control click and drag to do that. And notice what I've got right here. If I zoom in, I've got, if I move myself around, I've got, what does that look like? That looks like a robot, doesn't it? I got a little simulated robot in there, rocking. Okay, so I come over here and I open my driver station, because remember, the robot's not just the robot, it's the robot in the driver station. Actually, I'm going to zoom out. You can also change your view from the sideline. Oh, you can do it over here. Yeah. You can do all sorts of views and whatnot. I come over here and I have to go to Operation and Enable and my joystick. Hey! And there it is. And I'm moving balls and I'm doing all sorts of stuff. So the steps in the process are, to reiterate, you've got to open your driver station. You've got to open LabVIEW. You've got to make a robot project. Okay? You've got to open the robot main and switch to simulated and hit the Run button. Okay? Those are the 4 steps, and I'll write them down on a slide, and then we're at lunch. So be back here at 1:15. I hope this was interesting. I hope it was helpful for the...
Wants their own computer. We have 2 over here. And is this one working now? Yep. The third one over here we'll bring over, set right here.
I hope that was helpful to the mentors as a refresher of all the things that you have to remember to do. And I hope it was helpful for you guys as programmers. I know we haven't programmed yet, but we're going to do it after the break. Okay?
One last thing before you leave. 1:15 is 1:15. We're gonna have to get started at 1:15. So if you happen to be running a little late, well, that's okay. We're just gonna go ahead on, and you can run a little faster and catch up.